Now our motto, determine 4 pole long shunt. First of all, make the long shunt. Okay, so is the representation of long shunt, and this one VL load is connected, terminal voltage corresponding to VL. Okay, that is A1, A2, RE, RF, or you can say the RSH. Okay, now armature current, this will be equal to ISC, and here IF, and here load current corresponding to this one. Okay, now supply to 25 kilowatt, PL is given. PL this will be equal to 25 kilowatt, 10 to the power 3 watt written corresponding to this one. At terminal voltage VL is 500 volt. Given the armature resistance is given 0.03 ohm, and series field resistance RSE this will be equal to 0.04 ohm, and shunt field resistance RF this will be equal to 200 ohm. The brush drop VB this will be equal to 1 volt. Okay, the brush drop may be taken as 1 volt. Determine the EMF generator. Our motto, determine the EMF of the generator. Okay, so first of all, make the diagram corresponding to long shunt. Okay, now our motto, determine this voltage, EMF of the generator. I know that E this will be equal to V plus voltage correspond terminal voltage plus this drop plus V plus IA armature current going on this one, and also in resistance RA. So RA plus RS plus brush drop VB. Okay, now and what about IA? IA this will be equal to IL plus IF. IL, what about IL? PL is given, this will be equal to VL into IL. So what about IL? IL is written as PL divided by VL. What about PL? That is 25 into 10 to the power 3 divided by what about VL? That is 500. It means 50 ampere. Okay, and now second one, IF is written as terminal voltage divided by resistance, VL divided by RF. VL is 500 divided by 200, that is 2.5 ampere. So what about IL? IL is 50 plus 2.5, that is 52.5 ampere. Okay, IL plus IF this will be equal to 52.5 ampere. Now another way, that is 52.5 ampere. IA is 52.5. Now next target is determine, our next target is E. V I have already know that is 50 100. What about IA? That is 52.5. And what about RA? RA is 0.03 plus 0.04 plus 1, and this is finally a 504.675 closer. That is, this is the closer value. So first of all, make it. Now our motto, A 20 kilowatt 200 watt 200 watt shunt generator has armature resistance of like this one and shunt field resistance like this one. Calculate the power developed in armature. So first of all, make DC shunt generator. DC shunt generator make first of all armature like this one. This is load, that is VL, IL, and that is ISH, that is RSH, and that is generator, that's why IA is like this one, A1 armature. Okay, this is the DC shunt generator, that is DC shunt generator. Okay, so first of all, PL is given to 20 kilowatt. Okay, and VL is given 200 watt. Okay, so first of all determine IL. IL is PL divided by VL. PL is 10 to the power 3 divided by 200, so 100 ampere. This is 100 ampere. Okay, armature resistance RA is given 0.05 ohm and shunt field resistance RSH, that is 200 ohm. Okay, calculate the power developed in armature. Our motto determine EG. So I know that EG is equal to V. First of all determine EG, RA plus RSH. Okay, now next target is first of all determine IA. IA is IL plus ISH. IL is 100, but what about ISH? I know that ISH is written as VL divided by RSH. Okay, so VL, that is 200, RSH is, what about RSH? RSH is 200, so that is 1 ampere. Now if this value, that is 100 and that is 1, that is 101. Okay, now EG is, V is 200 and IA is 101 and RA plus RSH. RA is 0.05 plus, no RSH, only RA. Okay, so that is 200 plus 5.05, that is 205.05. Okay, now next target like this one. So power develop corresponding to develop in armature, it is written as EG into IA. EG is 205.05 into IA is 101. So finally we got 205.05 into 101, and that is 1 kilowatt. Okay, so make it